All right, welcome back for part two here, folks. One thing, I hope you got this note. I just look back at it. It looks terrible. This looks terrible, but maybe I'm out of practice with the old smartboard pen here. Um, what I wanted to mention, though, not that I have terrible handwriting, you already know that, is that this sort of thing is called derivative from first principles. Derivative from first principles. And it's the only way we know right now to take the derivative, but chapter two is going to be all about shortcuts. Like we're going to be able to know pretty quickly if this is the function, this is the derivative, or if this is the function, that thing's the derivative, and so on. We're going to be able to figure this stuff out quickly after chapter two, but now it's from first principles. And so when you see that, it means this long way. Okay. Um, Good. One more example. And it's a good example. Find the equation of the normal to the graph of that. And this is one of our reciprocal graphs from grade 11 or from advanced functions. We could sketch it if we want to at x equals minus 1. And first of all, what's the normal? What does that mean? We know what a tangent is. Well, what's the normal? The normal of a graph of f at point P is the line perpendicular to the tangent at P. So I'm not going to do an awesome sketch here, but I'm going to do a crappy sketch. Uh, let's see here. This is like a function sketch, right? A really fast function sketch. At minus 2, that's x is minus 2. There's a vertical asymptote. And I know that nothing else has been stretched or anything, so it's going to be something like this. And I could find this point, I suppose, x equals 0, y equals a half, dandy. But at negative 1, at x equals negative 1, we can see quickly, minus 1 there, this is the tangent. The tangent's like this, like that. There's the tangent, something like that. And we're going to calculate that. That's actually the derivative is the slope of the tangent. The normal is the line that's perpendicular to that. And you're supposed to remember how to find the perpendicular slope. Do you remember how to find the perpendicular slope? It's the negative reciprocal. What's a negative reciprocal, you say? Well, remember, if the slope is 2, then you flip it and make it negative. If the slope is 3/4, you flip it and make it negative. Right? So that's not so bad. We can do that. So what are we going to do here? We're going to find the derivative of this, find the slope of the tangent, find that red slope at x equals minus 1, and then we're going to find the perpendicular slope by doing the negative reciprocal, and then we're going to find the equation. So there's some steps here. Maybe I'll write those out. So derivative, and then find the slope, and then we're going to find the perpendicular slope, then we're going to find the equation. That's the plan. All right, so off we go. First, let's find the derivative. Are you going to use? Yeah, I'm still going to use the old school one. I'm not going to use the alternate method, and you could try the alternate method, but I'm going to stick with this one for now. The alternate method is that x minus a on the bottom when x approaches a, that sort of thing, but I'm going to stick with this one for now because I like this one. Okay, so a little rough work over here. I take out, and notice I've kind of just reassigned this f at x just so it matches my notation here, and that's all well and good. Don't worry about that. I take out the x and I put in x plus h. Take out the x and put in x plus h, and that's a plus 2. And I'm not worried about the minus 1 yet. I'm going to find the derivative first. Okay, so this is tidied up as just, don't need the brackets. And notice I'm going to have one, this is one of these fraction ones. So right away, I'm going to write the 1 over h out this way so that I can see what I've got inside the brackets. It feels like we've done these questions 100 times already, because now what's the strategy? Well, it's not multiplying by the conjugate. That's to get rid of the roots. What's the strategy for these fraction ones is a common denominator. And we're hoping that a common denominator will work. Well, what's the common denominator? Well, the common denominator is going to be a big long mess. So I need uh, a denominator that both denominators will divide into. And notice this doesn't divide into this. You know, there's pieces that are the same, but that's terms, right? This whole thing doesn't divide into this whole thing because the h is kind of in the way. Um, so how do I pick up the other thing that I multiplied by? And just like you knew it was going to happen, stuff disappears, right? X subtracts X. 2 subtracts 2. And what am I left with on the top? I'm just left with plain old negative h, right? Subtract h. And watch your style here. I know some people are getting lazy and not writing. We got to write that limit in each time, otherwise it's communication error. And then on the bottom, I get this mess. And then now, just like we knew it was going to happen. We've done these a few times now. And on the top, I've got minus 1. And on the bottom, I have x plus h plus 2 and x plus 2. And is it okay for h to be 0 now? Yeah, we can evaluate this limit. H is 0. This is actually going to be x plus 2 times x plus 2. So that we say, therefore, f prime at x is negative 1 over x plus 2. Oh, that should be squared, right? Squared. That's the derivative function. So to find the slope of the tangent at any point x of this function, I can use this function. So therefore, and notice that's step 1 done. Step 1, that we took the derivative. And now we're going to find the slope of the tangent. So the slope of the tangent is at x is minus 1. I'm going to use my derivative function, negative 1 plus 2 squared. A little calculator work. Hopefully, no, don't reach for your calculator. Holy. 1 squared is 1 minus 1. Or what, was this at minus 1? Yeah, it actually equals minus 1. Dandy. And then, what's the perpendicular slope then? The perpendicular slope is, well, what's the negative reciprocal of negative 1? So flip it and make it negative. Well, it's already negative, so I'm going to make it positive. So that's positive 1. Check, check. Now find the equation. So the equation, we're going to use our slope point form because we like that one. We have x naught is negative 1. What's y naught? Well, I actually have to calculate it, don't I? I have to put minus 1 in there. And I get f at minus 1. Have I done this yet? I don't think so. It's 1. Right? And my slope was 1. So I get the equation x, or y minus 1 equals 1 times x minus 1 plus 1. And so I have, in standard form, I put everything on one side. I got x minus y plus 2 equals 0. ITRA is the required equation. And can I sell that to you that that's got a slope of 1? It looks a little steeper than that, but I bet you I could sell that to you. Does that look like it has a y-intercept of 2? Certainly does. Certainly does. Even though this is a cruddy sketch. that I didn't put any scale into. All right, I think the homework, no, don't want to show you that, not yet. The homework is on the page. Notice that the start of the next unit, the next lesson called differentiability is on the same sheet. Don't start that. Don't worry about that until after the Unit 1 test at least, okay? All right, that's all I have to say about that.